All right, you are welcome again. Today, we want to consider double integral. How to evaluate double integral over a general or an indicated region. Okay, now let's take a look at this question without wasting much of our time. We have evaluate the double integral over the indicated region. The double integral over the region D e raised to power x all over y dA. And then the region D is the point x comma y such that y is greater than or equal to 1 but less than or equal to 2. And x is greater than or equal to y but less than or equal to y cubed. Okay, so this is the region that we are asked to evaluate. Okay, the region of the point, and you can call the region to be maybe the limit or the range. Okay, the boundary, the region that we are asked to find the area. So we use double integral to evaluate the volume or the area of a surface. You get it, right? Good. Now let's go. Here we see that we have a double integral, and then this is with respect to x and with respect to y, since we have our two variables x and y. And then the boundary or the limit for the region R, you say that it is from 1 to 2. That is, y is greater than or equal to 1 but less than or equal to 2. Okay, so that means we're going to say the integral from 1 to 2, that is the limit or the boundary from 1 to 2, and then the integral from the boundary or the limit y to y cubed. This is for x, right? E raised to power x all over y. We have dx, dy. So we started with the integral over the region 1 to 2, and then we see that this is for y. We say dy, right? Good. The integral from 1 to 2, the limit or the boundary 1 to 2 is for dy, and then the integral from y to y cubed is for x. Okay, so we see that here we have the inner integral and the outer integral, or you say the inner part and the outer part. So here we're going to take the inner part first, that is with respect to x. We're going to evaluate the inner part of this integral before we go further and evaluate the outer part. Okay, now let's go. We want to evaluate the inner part. The inner part simply say the integral of e raised to power x all over y dx. The integral of e raised to power x all over y dx. Okay, so for us to evaluate this, we are going to make use of u substitution. Okay, we are going to say let u equal to x all over y. This exponent, okay, this e raised to power x all over y, we're going to call this x all over y a letter. Let's use letter u. Okay, so if we say it is u is equal to x all over y, we're going to differentiate this u with respect to x. That means we're going to say du dx. And then when we differentiate this x all over y, it's going to give us 1 all over y. Hello, it's going to give us 1 all over y. From this place, let's cross multiply and make the x the subject. As we make the x the subject, we are going to say that we have y du. We say that dx is equal to y du. Why did we make dx the subject? We made dx the subject because the variable x all over y have changed to u. So we are no longer integrating with respect to x, but with respect to the new variable, which is what? u. And then what are we going to replace this dx with? So we make the x the subject, and that means we're going to replace the x with what? Y du. Now let's go. So here we say let x all over y be called the letter u. Now let's replace it. That means we're going to have the integral of e raised to power u. In place of the x, we say y du. You get it right? Good. In this place, we are integrating with respect to u. Is that true? Yes, that means that this y is a constant. We take this y behind the integral sign and then integrate e raised to power u. Now when we take it behind, the integral of e raised to power u is the same e raised to power u. So here we have ye raised to power u is the answer, okay? But you discover that we say u is equal to x all over y, okay? That means we're going to replace it here. In place of u, we replace it with x all over y. That means we're going to have ye raised to power x all over y. Now look at it. We want to evaluate the inner integral, which is the integral of e raised to power x all over y dx. We evaluate this integral and we have e raised to power x all over y. Okay, that means we have evaluated the inner integral and then the inner part, and it says ye raised to power x all over y. Now let's bring it. That means we're going to have the outer part of this integral remaining now, which is the integral over the region 1 to 2, or the boundary 1 to 2. When we integrate, we have ye raised to power x all over y over the boundary or the limit y to y cube. Then we have dy. We integrated with respect to x. So in this function now, inside this bracket, anywhere we see x, we're going to replace it with the boundary, the upper bound and then the lower bound, okay? Or the limit, the upper limit and the lower limit. All right, good. Now let's go. That means we're going to have the integral over the region 1 to 2. We have ye raised to power x all over y. The first time now, in place of x, we're going to replace it with the upper limit, and then the upper limit is y cube. So here we're going to have y cube all over y. You get it right? Good. Minus the lower limit. Now we have ye raised to power x all over y. In place of x, we replace it with the lower limit, which is y. Okay, so here we have the integral over the region 1 to 2 ye raised to power y cube all over y minus ye raised to power y all over y. Then we have dy. So here when we say y cube all over y, it's going to give us y squared. And when we say y all over y, it's going to give us 1. Okay, so that means here we have the integral from 1 to 2 ye raised to power y squared minus ye all in bracket dy. Is that clear? So here we have integrated the first part, and this is what we have. We have integrated the inner part. This is what we have. Now let's go further and integrate the outer part. Okay, so here let's pick them one after the other. The first side we are going to integrate is the integral of ye raised to power x squared dy. This last part now is with respect to y. Okay, so let's integrate this first part. When we say the integral of ye raised to power y squared dy, is still the same thing as saying the integral of e raised to power y squared times y dy. It's still the same, right? We just bring the y in front of e. Okay, now let's go. We are going to make use of u substitution. We are going to say let u equal to y squared. In this case, we have the integral of e raised to power y squared. We say let u equal to y squared, or let's call this y squared a letter u. Okay, now let's differentiate this u. We differentiate this u with respect to y. That means we're going to say du dy. Now when you differentiate this y squared with respect to y, it's going to give you 2y. You get it right? Good. Now, you remember in this place we say the integral of e raised to power y squared y dy. We're going to make y dy the subject. Hello. In this place where we have du all over dy is equal to 2y. We're going to make y dy the subject. First of all, let's cross multiply. When we cross multiply, we're going to see that we have du is equal to 2y dy. We say that du is equal to 2y dy. So we want to make y dy the subject. That means we divide both sides by 2. So dividing both sides by 2, we see that we have y dy is equal to 1 all over 2 du. So that y dy is equal to 1 all over 2 du. Alright, good. Now let's go. In place of this place, we say let u equal to y squared in the integral of e raised to power y squared. So in place of y squared now, we replace it with u, right? Good. That means we're going to have the integral of e raised to power u, and then in place of y dy, we say we replace it with 1 all over 2 du. Okay, so after this substitution, we see that we have the integral of e raised to power u 1 all over 2 du. Here 1 all over 2 is a constant. We take it behind the integral sign and then we integrate e raised to power u. So doing so, when we integrate e raised to power u is the same e raised to power u. So that means we have 1 all over 2 e raised to power u, but u is equal to y squared. In place of u, we replace it with the real value y squared. That means here we have 1 all over 2 e raised to power y squared. You get it right? Good. You know, in this place where we have the integral from 1 to 2 ye raised to power y squared minus ye in bracket dy. We integrated the first part and then it gives us 1 all over 2 e raised to power y squared. You get it right? Good. Now let's integrate the second part. When we integrate the second part, which is the integral of ye dy, is going to give us y squared e all over 2. It's going to give us y squared e all over 2. Now we have integrated the first part and we integrated the second part, and then bringing it together we have 1 all over 2 e raised to power y squared minus y squared e all over 2, and then the limit, the lower limit 1 to the upper limit 2. All right, good. Now look at it carefully. In this second part where we have y squared e all over 2, we can factor out 1 all over 2 there. When we factor out 1 all over 2, and then in the first part we also have 1 all over 2. So factoring out 1 all over 2 from these two sides, we're going to have 1 all over 2 open big bracket. We have e raised to power y squared minus y squared e. All right, good. So here we have the boundary 1 to 2. Okay, so let's place in the upper limit minus the lower limit. Doing so, we're going to have 1 all over 2 open bracket e raised to power y squared. In place of y, we plug in the upper limit, which is 2. Here we have 2 squared minus, in place of this y, we place it with the upper limit, which is 2. Here we have 2 squared e. Okay, close the bracket, minus the lower limit. Now we're going to have e raised to power y squared. In place of y, we replace it with 1, which is the lower limit, and then we have 1 squared minus y squared e. In place of y, we replace it with the lower limit 1. Okay, so here we have 1 squared e. Okay, so here let's go. We have 1 all over 2 e raised to power 2 squared. When we say 2 squared is equal to 4, that means here we have e raised to power 4 minus When we say 2 squared is 4, 4 times e, we have 4e in bracket minus the other bracket. We have 1 squared is 1. Here we have e raised to power 1 minus 1 squared is 1 times e is equal to e. The second bracket gives us e raised to power 1 minus e. And then e raised to power 1 is the same as e. Then minus e is what? 0. So we have the first bracket remaining. So here we have 1 all over 2, open bracket, e raised to power 4 minus 4e. Now let's use this 1 all over 2 and open the bracket. We will say 1 all over 2 times e raised to power 4 is going to give us e raised to power 4 all over 2. And then when we say 1 all over 2 multiplied by minus 4e is going to give us minus 2e. All right? Yes. So the double integral over the indicated region D, e raised to power x all over y dA, is giving us e raised to power 4 all over 2 minus 2e. All right? Yes. Thank you very much for watching. Please, if you are new to our YouTube channel, please subscribe, like, and share our videos. Let's take more examples. Stay blessed.